Okay, so here we go. So this first problem is a right-handed approximation to this first problem on the test, and they're giving us an n of 4. And so since our n is 4, our delta x then is going to be, we have to remember it's b minus a over n. So that'll be 2 minus 1. 2 minus 1 divided by 4, which will give me 1/4 as my delta x, right? My x sub I then is going to be a plus I delta x. So my x sub I is going to be 1 plus 1/4 I. Are we okay with that so far? Okay, so then I'm going to use approximations to do this. And so what I can do is, since we're going to use 4 and we're going to use the right end, so to find the first one, so think of it like this. Here's 1, here's 2. So my first approximation is going to be this one after a 1/4 shift over, right? So the first value that I'm going to use is 1 and 1/4 times 1/4 plus f of, now the next one is going to be after another 1/4. So that increment would be at a 1/2, right? If we add a 1/4, then this would be a 1/2 mark. And then another 1/4 would give us the 3/4, right? So this one should be f of 1/2 times 1/4 plus f of 1 3/4 times 1/4 plus f of 2 times 1/4. Does that make sense how I'm getting my increments? Do you want me to draw it a little bit cleaner? I can. Okay, cool. So check this out. So if I look at it like this, right? So here's my function. Here's 1, here's 2. Since my delta x movement is 1/4, and I'll do it in a different color, that's going to be 5/4 or 1 and 1/4, right? That will be 6/4, which is 1 and a 1/2. And then this one would be 7/4 or 1 and 3/4, right? So our function is a cubic. So it's going to look, and I'll do that in a blue. It's going to look something like this, right? So whenever I do my rectangles, different color, I'm going to use this point to make the first rectangle, and then this point to make the next one, and then this one for the next one, and then wherever that one is on the third one, right? Saying our curve did something like this. Does that help? Chris? Jason? Yeah, so, yeah. Perfect. So then from there you can see the first one. So since we're using that right corner, I'm using this 5/4, which is the same as 1 and 1/4. And then I'm using 6/4, which is the 1 and 1/2. 7/4, which gives me 1 and 3/4, and then of course the 2. Since it's right-handed rule, we're going to end with the right endpoint. If we're left rule, we start with the left endpoint. We never get to the right. If we're right, we get to the right endpoint. We never see the left endpoint. So now we have to find what these values are. So with a calculator, I'm going to go 5 divided by 4 cubed then times 0.25. So this will be 0.48828125 plus 6 divided by 4 cubed and that will give me 0.48375 and then 7 divided by 4 cubed times 0.25. Are you guys getting these values? Are you guys getting those? Okay, so then adding these up, let's see, 0.488282125 plus 0.84375 plus 1.33984375 plus 2, and I get that's going to be equal to 4.671875. And we want 4 decimal places, so my answer should be 4.6719. That's my answer. Are we okay with that problem? You okay with that? This is obviously the key. Why don't I multiply the 2 by a half? Why would I multiply by a half? The I did. So, so here, f of 2. So my f of x in this problem is x cubed, right? So then 2 cubed is 8 times a quarter is 2. Does that make sense, Jason? Oh, no worries, dude. I want to make it as clear as possible. So I thought by using function notation, but yeah, does that make sense? So all of those f to, here, I'll do this. So each one of these I plugged into the function to get the numbers, and then I multiplied whatever that number was by a quarter. And that's how I got those numbers below. Does that clarify for you a little bit more, everybody? Okay, cool. Yeah, please ask questions. If I'm not being clear, please. I know I'm not perfect, and I want to be able to help you guys. How did you find out the interval again? Okay. So the interval came from my delta x here, right? Which gave me a 1/4 shift. Do you see that? My 1/4 shift was right there. So since I'm starting from 1, my interval on this thing goes from 1 here to 2. So I have to shift over first, right? So if I start at 1, my first shift is 1/4, so I'm going to start at 1 1/4. Does that make sense, Josh? And then add 1/4 each time. Okay, and obviously this is our starting point, right? Is that lower bound 1? Just to be as clear as possible. Okay, so this next problem, it's a translation, correct? So it's saying write this thing as a definite integral and evaluate. So what is this thing as a definite integral? So if we know what a definite integral is, I can see, and I'll do this in little pieces for you, that is the function, right? So my function f of x is going to be x squared. Do you guys agree with that? My lower bound is 0. My upper bound is 2. And since we're dealing with it in terms of x, delta x means I'm dealing with dx. And so my integral is going to be from 0 to 2 of x squared dx. So when I do the indefinite to this, I'm going to, the definite integral of this, it's going to be this evaluated from 0 to 2. So I'm going to get 2 to the third over 3 minus 0 to the third over 3, which is going to give me 8 over 3 minus 0. And so my answer is 8 over 3. And you can check this with your calculator, right? Do you guys remember the steps to be able to check this? Right? They should be in your notes somewhere. Okay, now, the next question that I have is asking for it by using the definition. So we now know the answer, but what I'm trying to see is, can you do it the long method to confirm? So then we need to find some things, right? So our delta x now is going to be 2 minus 0 over n. So it's 2 over n. My x sub I is 0 plus I delta x, or it's going to be 2 over ni, right? So now when I use the definition, I'm going to get the limit as n goes to infinity of my Riemann sum of 2 over ni squared times 2n. Does that make sense to everybody from the definition? Okay. So then I'm going to square. So I'm going to go the limit as n goes to infinity of my Riemann sum, and I'm going to get 4 over n squared I squared times 2 over n. And that's going to give me the limit as n goes to infinity of 8n cubed, then the Riemann sum, right, of I squared. And that's going to be the limit as n goes to infinity of 8 over n cubed. And this piece right here, we know is going to be n times n plus 1 times 2n plus 1 all over 6, right? In doing the homework, have you guys gotten sick of these Riemann sums? Crickets. Jason. All right. So when we go to clean this up, I'm going to get 4 over 3 n squared, and then this is going to be 2n squared plus 3n plus 1. We still have our limit And then going through each, I'm going to get 8 over 3 n squared over n squared plus 4 over n plus 4 over 3n squared. And each one of these is being, the limit's being applied to it. And so what do we see? This is going to go to 0 and this is going to go to 0. And so we end up with 8 over 3. And that is the answer. But this is the steps that you need to take to do this problem. Are there any questions on this one at all? Nothing? Okay. How many have gotten those guys right so far? Okay, let's do the next one. Okay, so it's asking us to reduce if we have impropers and whatnot. So this problem is a definite integral. And so when we do the definite integral, I'm going to get 2x to the 8th over 8 minus 4x to the 4th over 4 plus 10x. And that's going to be evaluated from 0 to 1, correct? But let me reduce it. So I'm going to get x to the 8th over 4 minus x to the 4th plus 10x evaluated from 0 to 1. So that's going to give me 1/4 minus 1 plus 10 minus 0 over 4 minus 0 plus 0, which is going to give me a negative 3/4 plus 10 minus 0, which will then be 9 1/4, which is my answer. I try to make it very, very straightforward. Now the next problem probably is the hardest problem. For some people, it usually gets them stuck. And I don't know. I don't know why, but it does. So the way I'm going to do this problem is I'm going to break it up into two pieces. Because there's a minus sign in between, I can make this two integrals, correct? And since I can make it two integrals, I'm going to go the integral from 1 to 2 of x to the 2/3 over 3 root x squared dx minus the integral from 1 to 2 of 3x to the negative 3 over 2 over the cube root of x squared dx. And then I'm going to write them in terms of powers so they're easier to see. So this will be x to the 2/3 over x to the 2/3 dx minus the integral from 1 to 2. Bring the 3 out front. That's a negative 3/2 over x to the 2/3. Right? Do you guys understand that translation of the powers? From roots to powers? No? Yes? Maybe? Alright. Okay. Then what I'll do here then is I'll simplify. So this is from 1 to 2 of 1 dx minus this guy, which I'm going to simplify. So I'm going to go 1 over x to the 2/3 times x to the 3/2 dx. So this guy's going to become the integral of x from 1 to 2 minus, and this one we still have some work to do. So I'm going to do that work. I got to add those exponents, right? So 2/3 plus 3/2, 6 over 4. This will be 6 and 9. So that should be 13/6. 13/6 dx. Now, this ends up being 1, right? Well, I should show it. I'll go 2 minus 1 minus 3, and I still have this integral. Now, I'm going to move that up to be a negative exponent because it's easier to integrate that way. And so I'm going to get 1 minus 3, and then adding 1 to that's going to give me x to the negative 7/6, which will give me 6/7 negative. And that's evaluated from 1 to 2. So that's going to be 1 minus, or actually 1 plus 18/7 x to the negative 6/2 from 1 to 2. So 1 plus 18/7 of, let's do it this way, 1 over 2 to the 6th root minus 1. Are you guys okay with that so far? So I'm going to get 1 plus 9/7, the 6th root of 2 minus 18 over 7. And that will give me, since we want an exact answer, I'm going to get negative 11 over 7 plus 9/7, 6th root of 2. And that's good enough. I won't rationalize the denominator. We okay with that? Okay, that's the one for some reason that most people end up having issues with, but it's just a fraction world, and that fraction world causes headaches. Okay, here's number 6, and now this is the fundamental theorem of calculus. This is part 1, right? So in part 1, what we need to do is take the derivative of the integral. So can someone tell me what the derivative of that guy is? Anybody? Yeah, that's it. So that first piece is going to be 2 ln of x. Really, absolute value of x it should be, but that's okay. And then I'm going to multiply that with 3 minus 2 over x cubed, because that's taking the place, right? It's being plugged in for the t. And so that is my answer right there. Are we okay with that? Okay. Yeah, fundamental theorem of calculus part 1 is interesting for sure. Okay, next one. We're asked to integrate this. It's an indefinite, and since it's indefinite, What do we need to do? What do I have to add at the end for indefinites? Yeah, the plus C. So, okay, so what I always do with these problems is I convert them so that they are power rule problems. So now I have, this is my integral, and so I'm going to get x to the 4/5 plus 1 over 4/5 plus 1 minus 2x to the 1 plus 1 over 1 plus 1 plus some constant c. So that should give me x to the 9/5 multiplied by 5/4 minus the 2's will cancel there, and I'm going to get a square, and then plus some constant c. Are we okay with that? Now, I do have a question for you guys from WebAssign. When you're doing your homework on WebAssign, does it automatically give you the plus C, or do you have to add the plus C? Okay, that's good. At least it's making you do it. Okay, this is a tricky problem. We obviously have to use substitution. I told you have to use substitution. And since we have to use substitution with this, what do you think the U should be? All right, I'll just do it. This is your U, because it's the inside function of sine. Do you see that? So then I'm going to get U is cosine of 3x, and watch how cool this is. So when I take the derivative, I'm going to get negative sine 3x times 3, so dx. So I'm going to get a negative 1/3 du is equal to sine of 3x dx. And do you see, and I want to match it, this is this. And so when I do my integral, I'm going to get a negative 1/3 sine of my u du. See how easy it makes the problem? It super cleans the problem up, which is really, really cool. Now, the integral of sine is what? Yeah, it's going to be negative cosine of u, and then we have a negative 1/3 out front, plus some constant c that we can't forget about. So we're going to get 1/3 cosine of, our u was cosine of 3x plus c. And so this is our solution. Are there any questions on this one? Can you explain the last part? Which part? Where I went from, here, let me number it. So 1, 2, and 3. Which one of those? Number 2? Okay. So remember, when I have the integral of sine of something, sine of x, whatever it is, the integral of that is the negative cosine of x. That's just one of the rules that you have to have memorized. And so that's how sine became negative cosine. The 1/3, if that's what you're asking about, the 1/3 came from here, the 3 and the negative. So when I divided to the other side, it became a negative 1/3. And then I always have to add the plus c if I don't have an upper and lower bound. Does that make sense, Chris? Okay, you okay then? Okay, cool. Okay, the next problem should have been familiar, and you guys should have done it on your own on account that I think I did this problem in the notes, right? Did anyone recognize this problem? Or I did it as one of the homework, one of the worked out homework problems. If you looked at the homework problems that I worked out from 5.4 and 5.5. This problem here, the key to this problem is to breaking it up. And so the integral is 1 over 1 plus x squared dx plus x over 1 plus x squared dx with the integral there. And yeah, it should have looked familiar. So this first one here, we know it to be tangent inverse of x plus some constant, right? This second one, though, we needed to, in order to be able to do it, we needed to have a U-substitution. So our U-substitution was going to be the denominator. So then I'd get 2x dx, or 1/2 du is x dx. And so tan inverse of x plus some c1 plus the integral of 1 over u du, but with a 1/2 in front. The integral of 1 over u is what? Yeah, you guys are getting it. So we're going to get tan inverse of x plus c1 plus 1/2 the ln of u plus some c2. So then tan of x plus 1/2 ln of absolute value of 1 plus x squared plus some constant c. I don't know what the heck that was. Weird. We get that as a solution. We okay? Okay. Man, you guys are letting me fly. I guess you guys don't need much help. Number 10 is pretty tough. Can you explain the 1 over u, please? How I got this piece right here? Okay, so here's my problem, right? So when I have this problem here, the 1 over x plus, or 1 plus x squared piece, if I make my u that 1 plus x squared, ooh, this should be an x, but that's okay. If I make my u the 1 plus x squared, doesn't that become u, the denominator piece? Jose? Yeah, so if that becomes the, And then the du piece gave me the 2x dx. So when I go 1/2 du is the x dx, the x on top gets taken care of. So I only get 1 over u, and then really I can put 1/2 du, and then that goes out front to give me that. Does that help? Well, yeah, it basically, so let me explain this to you so you can get it. Because I want you to be able to totally get what's happening. So when I look at this piece here, right? That is the same, and I'm going to use a different color, as 1/2 du. Correct? So the du and the 1/2 is what happened to the x dx. So that's what happened to this part of it. So you see how the orange piece becomes 1/2 du, and the u part just becomes 1 over u. Does that make sense? Okay, you're good with that then? All right, cool. All right, now I'm going to give you guys a bit of a toughie. Can we do web assignment problems? Oh, yes, for sure. That's what I said I was going to do today. So after I did the practice exam, I would answer web assignment problems for you guys. I'll stop the recording though after I finish the test, the practice exam, so people don't have to watch a bunch of stuff. Okay? All right, so here we go. Okay, so this is a toughie. So this is obviously a U-substitution problem. What do you guys think the U should be? No, not the 4x squared. It should be everything under the root. So my u should be 4x squared plus 1. Yeah, everything inside of it. So then what I'm going to get is du is 8x dx, right? So then I'm going to get 1/8 du is x dx. Now, we run into a problem here, my friends. Are you guys ready? 1/8 du will take care of x and dx, which is great. So I'm going to rewrite our problem. So I'm going to go, okay, there's an x squared, there's a 4x squared plus 1, and then there's x dx. Do you guys agree? I've written it in a way so you guys can see what's happening. Yeah, I have an x to the third. So look, the du piece, the x dx is going to be this. So no problem. That can become du. I have the root of u. But look what's left. What's left still that's in terms of dx? Do you guys see it? So here, I'll try to make it blatant. So this piece right here is this. What isn't highlighted? No, the 1/8's out here, and I should have had that. That would go with the orange. So that would be this piece, right? The x squared piece is there, right? So that means I need to do something here to take care of x squared. So if I solve that for x squared, I can substitute that in terms of u. So I'm going to go u minus 1 divided by 4 is x squared. So now that means that over here I have to go u minus 1 divided by 2. And now these two integrals are equal. Does that make sense to everybody? Ooh, why'd I put this? Should be a 4. My bad. I just like making up numbers. Yes. So it should be a u minus 1 divided by 4. Because, so if I look at this thing, I have u is 4x squared plus 1, correct? So then when I subtract 1, I'm going to have that. I want to have x squared by itself. And I want it written in terms of u, so that is my x squared equivalent. So u minus 1 divided by 4 is equivalent to x squared. You guys get that? That's the crux to this problem. So then right here, what I'm going to do is I'm going to pull the 4 out. So I'm going to get 1 over 32 integral of u minus 1 times the root of u du. Now what I'm going to do is I'm going to distribute. So I'm going to get u to the 3 halves minus u to the 1 half du. Is everyone okay there? Okay, then from here, I'm going to go, all right, 132 times u to the 5 halves, so that's 2/5, minus u to the 3 halves, so that's 2/3, plus some constant c. And we can clean it up, so what are we going to get? What's 16 times 5? Is that 80? So I'm going to go 1 over 80, 4x squared plus 1 to the 5 halves power, minus 16 times 3 is 48, so 1 over 48, 4x squared plus 1, to the 3 halves power plus c. And that's my answer. We okay with that? Okay, so I'll show you. 1 over 32 times 2 over 5, that becomes a 1, that becomes a 16. So 1 over 16 times 5, and 16 times 5 is 1 over 80. Does that make sense, Jose? Okay. Do you get how I got the 48? Okay. So there's that one. That's number 10. Let me do this last one for you guys. And then again, this is by substitution. So what do you guys think the substitution should be? In this problem, the inside function seems like it would be the solution to it, but in actuality, in this one, your u should be ln of cosine of x. And I'll show you why. So I'm going to change my integral a little bit to be sine of x ln of cosine of x over cosine of x dx. And I'm even going to rewrite it differently than that. I'm going to write it, how about this way so you guys can see it? Sine of x times ln cosine of x. Actually, let's make it super clean. Ln of cosine of x times sine of x times 1 over cosine of x dx. Do you guys agree with that? That's the same thing as what I have above. Cool. Now, when I do the u here, the du, what is the derivative of ln of something? So the derivative of ln of cosine, shouldn't that be 1 over cosine of x times, now I've got to take the derivative of the inside. So what's the derivative of cosine? Isn't that negative sine of x dx? So then I'll bring the negative to the other side. And I'm going to write it so it looks just like I have it. So, isn't that this piece here? So the only thing I need really is a negative. That's going to be negative du is representative of the orange piece, correct? And so what was my u? Isn't my u what was highlighted? Or what is not highlighted, the ln of cosine? So that's just going to be u. So when I do the indefinite, I'm going to get negative u squared over 2 plus some constant c, which is going to give me negative ln of cosine of x over 2 with this piece being squared plus c. You guys got it? Any questions on it? You're okay? Okay. All right. Then I'm going to stop recording and I'll answer some homework questions for you.